All right, perfect. Okay, great. First off, thank you so much, everybody, for making it to our 8th edition of our meetup. And just a quick few things. First off, I'd like to thank Cisco for being an awesome host. So if you don't mind putting your hands together for Amy and for Klaus for organizing this whole thing. Thank you so much. And Klaus, right back there. Thank you. Second order of business, for those of you who are looking to connect to the internet, I know that this is probably the most popular question in all of meetups. What is the Wi-Fi passwords? And it's in a small piece of paper, and it's on top of that corner right there. Feel free to pick it up and use it to log in. It is the same login and password for most folks, so if your neighbor has it, feel free to go ahead and use it as well. So we have a really interesting session organized for you folks today. We have Vipin, who's going to go ahead and kick off a conversation about content. He's got his slides up already. The last piece of information for you folks is once the talk is done, when you have questions, please walk up to the microphones that's right up in the middle of the aisle and use those to ask your questions. These are being recorded. That's one of the reasons why it's kind of nicer if you speak into the microphone. And in case for the presenters, if you do hear questions that are not from the microphone, please feel free to repeat them before you answer them. That's about it. So with no further ado, let's get started. Please put your hands together for Vipin from Cisco. He's going to talk to us about Project Contiv.
Yes. Hi, everyone. My name is Vipin. So, I was starting to play with containers and trying to see what it takes to operationalize them. And, a few things came out. And I put together my thoughts as to what it takes to automate the policies. And I'm going to share that with you, hopefully with some of the live demonstrations as well. First of all, who am I? So I'm a developer. I'm one of the chief contributors in Contiv project. I'm a networking enthusiast and Golang fan. Lately, mining those blue pants and, red containers. A word about Contiv. This talk is not so much about Contiv. I wish there was more time. I need like 4 hours. But what we'll do is just a quick word about what we do in Contiv is we do networking for containers, multi-tenant, multi-host networking for containers, security, load balancing, policies, and telemetry for applications. There's a meetup coming in this building, Kubernetes meetup on Thursday, where we talk about application telemetry. I encourage you to sign up for that. Then there is physical network integration, of course, storage for containers, persistent storage for containers, and then doing policies for allocation, garbage collection, snapshotting, IOPS rate limiting, all those stuff, and supporting Ceph and NFS backends. Clustering to provision nodes and bring the entire cluster up. This is not Kubernetes clustering. We use Kubernetes Swarm, Nomad, or Mesos as the scheduler. So this is all open source. I mean, this could be your story if you want it to be. So feel free to hack on it, and contributions welcome. If you think that you want to build something on top of it, some people have done it, deployed this in AWS stack, and it works just nice for them. And of course, Contiv is sponsored by Cisco. I'll zoom through some of these slides quick, but this is like I started thinking about why and what. Why do we need policies? Is it really important? If I can spin up my containers, why do I need policies? And you need it because you want resource acquisition to be predictable. You need it because you want security and compliance to be put in place. You need it because you want prioritization for various resources and all that. You need it because you want to know who does what and whether it's allowed or not, those things. And then you need it because you want log trails, completely knowing, basically getting the grip of your deployment for applications is why you need policies. And then, let's talk about specific use cases because these are like, general good stuff that anyone can talk about. But let's say, I have a database that could only be reached on some port 27017, for example, on TCP. Everything else should be disallowed towards that database. Or that, application tier can only be reached by the web tier of that application composition. So those kind of things are the examples. I could say that, my production job needs to get better resources and resource acquisition. That is another example of, CPU, memory, network, storage, which is SSDs and all that. How to carve that resources out to create some of these things done well. Maybe restrict some developers from running some applications in a specific network. So if I have a production network, maybe I don't want someone. I hope there's no one Joe here, but yeah. So I mean, you could carve out these kind of rules, ensure that you have prioritization for infrastructure containers. So the world is going to be consisting of two kinds of containers. There is infrastructure containers and there are application containers. So infrastructure containers need to probably get different priority than your regular application containers. So how could we get that isolation, all that done? So I already talked about logging, and there are many things like this. What I want to do is take time to describe what are the mechanisms to do these, implement these policies. So for predictability and resource acquisition, I could use scheduler-specific constraints, or I don't know if you are familiar with admission control and authorization plugins, which are available in Docker and Kubernetes ecosystems quite widely. There are a lot of Linux tools to be able to do that, LXC, Netlink, libraries, and block IO, rate limiting, those things. For security and compliance, I could use IP tables, eBPF, open flow data paths to enforce who talks to who and those things. I'm specifically zooming down from networking point of view here, but you can imagine similar things apply for other things too. And then there's a project that Cisco is sponsoring called Fast Data Path fd.io. You're welcome to check that out. But you can do that in custom data path using DPDK, so that it's all done in the user space. So those are ways to apply some kind of network security policies, for example. Prioritization is another aspect. How to do that? Use some kind of inbuilt tools from Linux, like OVS policers or marking and DSCP and traffic shaping and rate limiting inside Linux kernel. Or you could write some custom schedulers to be able to do that. Access authorization is the very key part of policies. The policies are completely not there if you do not tie it to who can do what. And even if it means that I want to allow everyone to do everything, that is a policy. At least you need to be able to state that, yes, allow everyone to just do whatever they want. That's your maybe default policy. That's what is happening today. But I'm talking about what if you have to do things more on top of it. Monitoring, you could do some kind of REST routers to do that. And Linux has a lot of tools to do the monitoring, strace, sysdig, and artitkernel, and those type of functions. So there are many tools that are available to create these infrastructure so that you can do the kind of enforcement and all that. But the question always comes back as to, on my side, I want the green life, but policies pulls me towards red, which is really that policies are governance and restrictions and all those things. Automation is freedom, simplicity, consistency. So how do you get the balance between two? And that's what the automation of policies is like. You get the right structure, and then you put the automation to it. So it's not a very trivial task, of course, but I'm going to talk about few things that, from my experience, has been quite relevant to make it happen and easily. And we'll of course jump into demonstration right after. So division of responsibility is a very key aspect of automating policies. So this slide, I want to go a little slow. Any questions on until now? OK, good. I think we'll come back to some of these things, and it'll occur back as to what I was talking about when we look at live demo and those things. Division of responsibilities include that where this responsibility lies. If that is divided cleanly, then automation is quite possible. For example, I could say that it is application developer who's going to specify what ports you want to expose as applications. And then operational ops person trusts assigned image. So application person has created an image, and the application is signed container. You know that it's trusted. It's in a valid repository and all that. Maybe I can trust what application developer wanted from that. This is not what application is trying to listen on. That's different. This is the information which is burned into the container itself as a metadata in the container. So that could definitely help automate what application developer wants versus what you want to enforce. And we'll look at some of the examples for that. Using templates actually helps quite a bit too, of course. Provide a way to refer a template for well-understood behavior. You can say that these are, likely you're going to have like 50 behaviors in a big data center of, let's say, 50,000 containers as to how you want applications to do various things. If you have 1,000 or more, there's something wrong with it because you are not going to really make sure what's happening if you have that. So it is possible to create those 50, 100 templates and then say that, I will just, latch onto one of those templates and then tie users to say which user can access which template. So that's a part of it. Auto-tuning is something, very interesting aspect of, sometimes you don't know what needs to be automated completely. But what you do is you start off with something, whatever's there, and then, then lock that in afterwards, discovering connectivity to finding out whether application needs X kind of storage resource. Maybe the developer says that I need 10 gig, please, but ultimately, from history, you have seen that this application never uses more than 10 meg. So maybe you can do something about it by creating the policies for it automatically, like saying that this application only needs this much of storage, and help the resource utilization to be really better overall. Integrating roles and responsibilities is a very key part of this whole thing. So anything that you do up top needs to be tied to roles and authenticated users. So you could say that if you are DevOps, then so-and-so network is only accessible to you, or if you are so-and-so person, you cannot run a container in my production network, or if you are test application, I cannot give you 10 gig of storage. Those kind of things has to be tied back to the user to make it complete and sensible. So with that, I want to jump into demonstration very quickly as to how that could look like when done. At least one way of doing it, of course. So in this example, what we'll look at is there's an operational intent which is in red because it's always hot red boiling thing that you want to make sure your network is up and running. But this is a cool application developer in blue where we will go and launch the application. So it could be the same person, but I'm defining the operational policies defined by someone who gets to say what happens in this operational deployment of containers. And then application launching happens using your standard tools, application blueprint tools. So I'm going to use Docker Compose if people are familiar with it. So step 0 is already done, which is preparing infrastructure, because I brought up 2 VMs. In case of cloud, you bring up the VM somewhere else. In case of home infrastructure, you start some of those servers, bare metals or whatever. So step 0 is done. We'll start from step 1, 2, and then keep playing with it as we go. So with that, let's go to, is the font visible to everyone? OK. So at this point, I don't have any networks created. Netcurdle is another way of contiv networking commands to check out what networks are created. So it's the same as, so this is the standard Docker stack that when you bring up, you see that these are the default drivers which are already loaded. So I'm going to run a small script which just creates 3 networks. I'm going to call them dev, test, and production. So let me just go ahead and do run sh. So at this point, we have those networks created. You see that driver is net plugin, which is the contiv networking driver. So we have these 3 networks created. Let's look at the ops policy, how it looks like. So here I have a simple ops policy, which is like my user admin has access to all networks and can use all kinds of policies. So this is like my Uber user. He can do whatever he wants in the network. This could be my default policy for all users. A user could be all, and then I'm done with it. I don't need elaborate policies at that point. But what I've done instead is I defined another user called vagrant user, which is what I am currently logged in as. And that has access to only dev and test network. It does not have access to my production network. And then it cannot access all policies which are defined here. It can only access trust app and Redis default and web default policies. Trust app is a very unique policy, which I'm defining it to be permit application. This means that whatever application developer specifies, allow it to take in. So this is more of an example of a policy which is a network permission, which tier of an application can talk to other tier, that type of policy. And so similarly, I've defined a couple of other policies, which is saying that Redis default allow these ports on TCP and let it be. Web default allows ICMP and TCP on port 80. But you can imagine that these policies doesn't have to be network isolation policies. They could be storage allocation policies to other ones, depending on what functionality we are interested in. So if you go back to Contiv page, you can check out what all policies are exposed out to the users. But I'm going to use this as a demonstration here. So there is also one which is called default policy. If user doesn't specify that, what do you want that to be there? Which means that you have set a base, you know what is going to happen if you start an application in this. So having looked at this, if you just remember that there are 2 users, 3 networks, production, dev, and test, and there are like 3 override, 4 policies: allow all, trust app, and my Redis database and web database. So with that, right now I just have one DNS container running here, which was started 21 minutes ago. Any questions so far? I just want to go very slow on the demonstration as opposed to slides. Slides, I just zoom through it. But any questions? Yeah.
I assume this is a very simple case, right? So what is the scale of policy you're looking at from compute, network, and storage?
It could be thousands, no questions. When I say thousands and instantiated hundreds of thousands, if you combine the combinations of various things, it could be very high. But when you're talking about the number of combinations that you want to templates and profiles, I won't think that there will be thousands of them. You could very easily say that these are, you could pick it up from the applications and all that. When they're instantiated on the host, there could be thousands at a given time. If you're running like, let's say, 200 containers or 500 containers on a host, or bare metal, I mean, you could easily go up to 5,000 rules very easily for networking alone. So I'm assuming that that's the level of scale that will be of a target.
So do we see a problem in terms of scale when it comes to policy, specifically when you go as granular as what you have shown here?
The granularity that I've shown here really works with user-level things. And when you go back and look at those things, it's OK to define these things up front. And definitely, it should be able to work scale-wise. Yeah. Yeah, we have tried up to thousands of 4,000 or 5,000 rules, these kind of things for networking quite easily. For storage, it's only mostly allocation time. The snapshotting and all that is in aftermath. Yeah.
Yeah.
We'll keep some of the questions towards the end.
OK.
We'll keep about a few more minutes, but I'll let Ananta finish.
Yeah, just to follow up on that, something like, you mentioned like low role-based access stuff, right? Typically, in most of the cases, same role may have a different sort of behavior on multiple targets.
Yeah.
So if we put that into mixture, then the scale, again, becomes an issue, I guess. So
yeah, I think what you need is what you're talking about is a language to define these policies. Because once you define the language right, you can always do the matrix multiplication quite right. What I'm not doing right now is defining the policy language itself, which is a much more elaborate subject to have a discussion on. Maybe we should talk about that. If you choose the definition to be defined properly, then to me it's not like an unachievable task. Okay, so I mean this is a very simple example. Of course, this is picked up from Docker website, and so what, for example, I could do is I have actually a modified version of Docker Compose, which I call Contiv Compose, which is hacked up version from libcompose. If anyone of you have played with libcompose, anyone knows what libcompose is? Cool. OK, so yeah, so that's like, oh, yeah, Rancher, yes, absolutely. So, basically, started to run all these REST calls into Contiv networking as and when this application is launched. So in this case, if I were to launch this application composition, you see what's happening here. It says that using default policy, because I didn't specify anything in my composition. And then it says that fine, for vagrant user, I'm going to use trust application. Because I'm trusting application, I'm fetching all this information from the application image to automate my policy creation and all that, which means that if I were to do Docker exec, let's see what all is running first. Let's make sure that it got, it was allocated a default network to be associated with. So I know that, so it got an IP address from 10.11.1.2 network. And then if we were to look at, then we see that, can you guys see it? OK. So this is my dev network is where this container belongs to. If I were to go into the container, So now I'm inside a container. If I were to run, let's say, some kind of tooling to find out which all ports are open towards my database tier, so I could run netcat on this port with a timeout of 1 second towards my demo Redis container. And you see, we are in the demo web container right now. And if I were to go into demo Redis container, I could, let's say, scan port 6370 to 6380 here. And then, we'll see, as you see that, 6379 is the only port that is open because we picked up this information in this range to be allocated from this pool because I was allowing 2 ports to be opened up on TCP. So everything else is timing out. Now, this is very different. Timing out is different from, something being silent. If network drops a packet, it'll time out, as opposed to it being silent and not talking about it. So we'll see in the later example as to if application were to listen on that port, then it'll still time out on this. So that's like, you created a policy for a user based on the default, settings, and you say that, it's trusting an application to derive the port information. So go ahead and, start deploying that. So with that, let's play with it a bit more, So what if, so I'll stop this composition, application composition, and this time we'll try to, launch this composition in a different network. We had created 3 networks, so we'll try to put it in my production network, let's say. So if I were to do this, and let's say I put net as production here. Is it making sense? Yes, no, okay. So I made it belong to production network now. So if I were to launch this now, it says Vagrant is not allowed to run in production network, all that stuff, good stuff, right? So now if I'm going to log in as administrator here. And go back to the previous location and do the same thing again. So this time, because I'm a different user, it should allow me to run these containers in production, in production network. And so if I were to bring the composition up, you see that it's saying, hey, allow all, and life is all beautiful. So this is go for it type of user. So if I were to look at these containers and grab their IPs, for example, can you guys see the thing at the bottom? OK, just want to make sure. So you see that it has allocated IP from 1033.1.2 network. And if we were to do Docker, that is my network, which is 1033 is a production network. So based on my role, now I'm able to launch the same application, which I could not in the other case. So I could, let's say we stop this, and this time what we'll do is we'll try to run the previous application back as a Vagrant user and try to scale out an application. And the good part is that it should automatically work for, it doesn't matter how many instances I'm running for a given application, right? So if I were to exit this, I'm back to my standard composition here. And we know that Vagrant is allowed on test and dev. So I'll make it belong to test. And then try to bring this composition up. And so it did what it did before, except that this time I'm going to, and of course it created these containers in my test network as opposed to the dev network earlier when we did that, because I specified in the Docker composition that my network has to be test here, right? This is standard Docker compose format, not changing much there. So what is happening is that as and when these containers are starting, I'm making REST calls to Concave networking to create the policies, to know what network they should be associated with and all that. That's the part of automation that I'm talking about. If the tooling is built in and the authorization plugin and the auth and authentication plugins are done right, then they could know that this user is allowed to do this operation or not. So couple the operation allowing with whatever information that you have to define these policies and all that. So this time I was saying that we'll go ahead and scale this application. So if I were to do Concave compose, and let's scale it to how many, maybe 5, 10 instances, OK. So I'll scale web tier to, let's say, 11 for fun, right? So I have like now 11 instances of web tier which are being spun, and they are up right now. So I have all these containers running. They all started like 4 seconds ago and all that, right? So now if I were to go in and do Docker exec on any of those web tier containers and try to run the netcat, it should enforce the same policy that it was for the other ones. That's the point, that you can scale out and scale in the application and still allow you to get the policies independent of that. Coming back to one of the questions that was asked, how to scale that? The way we are scaling is that we just create one group for every microservice tier and apply policy between groups, as opposed to creating between every single container. So you don't need to create the policies for every instance of a container. Rather, you can create one policy for the group of applications. There's a concept in Cisco ACI Fabric, which is called endpoint grouping. So it's kind of mimicking that. So yes. So I think in this case, if I were to run the same netcat tool from Web 7 tier, because I'm in a different instantiation of that container now, and if I were to do this, then it should work if my code is right. Yes, it should work. OK, so this is the way, then because we have scaled it, it doesn't change how many containers are being instantiated. And this could happen across cluster of multiple nodes, hundreds of nodes, and it still remains exactly same. So that is like, just doing basic stuff. Now, question is like, what if I want to override it? Maybe I don't want to go with, hey, read it from application type of policies. Maybe I want to override some behavior to say that, this application should use X, Y, or Z policy underneath as and when it gets instantiated. And that's a good requirement. Yes, you should have a way to override whatever application developer is talking about. So you could say that policy that you want to apply for a given container could look like. So in here, this doesn't change. So I'll let it belong to the network, which it is. But the policies that I have to define. So this is the policies that we have, right? I could always say that permit app and permit additional things, which means I want to allow whatever that application is permitting. But in addition, I want to also allow these 2 ports because I do some logging on those things, and application developer doesn't know about it. So you can create these profiles. It goes back to the question of how to not explode the combinations. So you can create these profiles to say that allow the profile which allows you to talk to the log servers, and then you can include that, which could include n number of instructions, and then keep it all in control. So you can say permit application and then allow X, Y, Z on top of it. So you can augment whatever user is specifying as opposed to just completely overriding it. On the other hand, this type of policy, like Redis default, can completely override it. Because there's no permit app, you can completely override whatever application is talking about there. So here, what we want to do is, instead of using the standard policy, I want to override it with Redis default policy and see, if I could get that. So first thing that you have to do is then, this application developer has to, let's say, specify that he needs to use labels. Yes. And then I want to specify, let's say I want to specify some junk policy here, right? Let me launch this as a different project, just for fun, So I'm launching this as a production project, really, as opposed to the standard one. OK, so here you say that Vagrant is not allowed to use policy junk. Of course, policy junk is not defined, but because it's not an allowed list, it's complaining about that. But if I were to go and edit this to call it Redis default, then I could, I should be able to run this. OK, so now it picked up Redis default, and then Redis default was allowing various ports, which was different from what the Redis default container was allowing, which means this is like a complete override from whatever application developer was specifying and saying that I want to go ahead and just specify these things to be permitted, for example. So now if I were to exec into the container, Not in the demo, because this was my prod project. And okay. So as usual, I'm given an IP from a network. Clearly, the network is decoupled from policy domain. You can have one big giant network and create all these groupings of various containers to be independent of the network. So which network you belong to is different from which policy domain you belong to, and then how you enforce it for the end user is a separate thing. So just because a container belongs to a given network doesn't mean he has access to everything that is in that network. That's what this thing is, where we are completely decoupling the network from the policy domains here, right? So if I were to run netcat now, it'll look different because I'm allowing 3 ports out of that 10-port range, and so what you will see is that it will not complain, or rather it will not talk about. Yeah, we'll look at the maybe we can look at the policy again here on this slide. Yeah, so 79, 78. Oops. So 3 ports, right? 77, 78, 79. So we go back here and try to run the same command that we did before, but this time we do it to prod Redis as opposed to demo Redis. And we'll try to reach the other container from here. So right now there are 2 apps running. We'll look at that very quickly. So for this one, if I were to try and reach to the prod Redis, which is the database container from my web tier, and try to see what all can be accessed from here, you see that it is saying 79 is open, but 78 and 77 it doesn't say connection timed out, because it is reaching the TCP/IP stack of the namespace of a container, and then it's not open, as in it's not created. So connection timeout happens only for the ports which are not permitted by the network layer. For example, in this case, Contiv network layer. So this demonstrates that we can actually go ahead and override the policy and say that just use this as the primary mechanism to run this. So now that if you see there are boatload of containers running now, not that many though, maybe 12, 15 containers running. So we have 2 applications. One is demo application and one is production application. This is my production application here. So we went into production web tier and tried to do this operation. But if I were to do this for demo Redis container, then it should ideally time out for everything. That's the whole idea. Because even if they are all belonging to the same network, you are only giving access to the application tier, which is launched as a wholesome unit. In case it could be a microservice or something like that. So now my production web database cannot access my development or test environment or demo environment, but vice versa. The same thing will happen otherwise. Let me pause here for some questions. We have about 12, 13 minutes left. Any questions before I move on? Questions? Are people following this, or am I going too fast or too slow? Definitely not slow. Okay. Yeah.
Will you be walking us through where the filters are happening for the ports? Is it an open flow?
Yeah. Okay. The question was, I'll repeat the question. The question was, would we walk through where the policy enforcement is happening in this whole situation and all that? Yes, we will. If time permit, yes, we'll go through that and all those things. If there is any high-level questions on why, what, where, then we can. This is a good time to pause and talk about that.
We have some time. Since we started a little later, we have about another 15 minutes. So feel free to jump in. If you have any questions, please, folks, remember to use the mics and come on over. We have some time for questions. While people are figuring out what to ask, I did have a quick question.
Sure.
You mentioned that the policy language specification is a long conversation, but how do you see that even meshing with how what you have in mind for Contiv? How do you see that combining?
Yeah, I take for example, Ansible as my right, the role here, right? How you could specify all these things in details and do all kinds of things with Ansible, provided the right modules are picked up and all that, and yet get it in a very simple way. In my opinion, it's a very simple way of, like, for example, doing installation and bringing it up. It should be of something of that nature where we don't expose the complicated, I mean, ultimately, yes, you can throw Python at people and say that write it in Python, you can do it. That's one way to do it, where you go completely programmable and you specify various objects and do it. Right. Other way is that just allow them to use YAML type of configuration where you specify this in kind of like Ansible format. Right. But what I showed was not that. But I'm talking about that would be the ideal way of doing it.
Nice, that's awesome. All right, we have a next question.
Thanks.
Yes, I'm curious to know why the policies are attributes of something called a network versus an attribute of the endpoints themselves, the application functions, the containers. And there's
go ahead. Yeah.
I'm sure there's a very layered and complex answer to that, but just philosophically, where do you come down on that?
Yeah, I mean, philosophically, they are not layered, actually. I think you probably missed me if I was communicating that networks and these things are related, groups and all that. Grouping of an application is an independent function that could happen. But are you saying that, why are groups defined under a network?
Well, I saw in your demo, you moved, you changed the network that a container was on. Mm-hmm. And that changed the policy to that endpoint. No, it didn't?
No,
okay,
it didn't.
Then I misunderstood.
Let's go back. I don't think if I communicated, I'm glad you brought it up that accidentally. The policy is determined by what labels you put in. This label is independent of which network it belongs to. In fact, I was saying that network and policy domains are completely independent with this implementation because, why should I create a subnet or a network just because I want policy isolation? That doesn't look good. So it is definitely not that. Now, could you have multiple of them, one for isolation, one for something else? Absolutely, but that's the goal. The goal is definitely not to mix these things. I could, for all you know, remove the network from this application, and still this application tier is going to get this policy because that's what he's using. And then we tie that to user to say that this user, is he allowed to use this policy or not? Yes, go ahead. And if it doesn't, we reject it. But to me, application developers, DevOps person's job is now very simplified. You just deal with application compositions and blueprints and just run them. To me, I think this is like an example. I'll post the code and the pointer to this if anyone wants to try this on their own, on their laptops, or play with it. I'll send the pointers to the code and also README as to how you can get this exact environment that I'm talking about in your own labs or laptops. Any questions?
One last question. Anybody else? OK, I'm going to jump in because I have one, because I think the demo was pretty awesome. And I have a quick question in terms of how do you actually see these tags evolving? Again, this is going from a perspective of management. Mm-hmm. I'm thinking more in terms of, like, I have a, like Bhargav or Ananta that asked a question before in terms of the scale. I'm just more curious in terms of, I know that YAMLs can be organized, I know in a specific fashion for you to, like, introspect. But if I wanted to know at any given point, hey, which policy is firing on which set of my applications, sort of like a state management of what's really happening.
Correct.
Would I be able to just go ahead and look at the metadata that's available to me with respect to the containers? Just take a look at the Docker inspect, see which tags, which labels have been associated with it, and then use that?
Yeah.
Or do you have something more
So first thing we need to do is, let's say, how do I know that Redis default is the policy I could use? Like, that's your first question.
Correct.
Very basic.
Exactly.
How do I know that Redis default is the policy I should be using, or all that? So based on the user, if I query the ops domain, I should be able to get the policies that I could use. Right. Which means based on my user, I should be able to query, show me all the policies. Mm-hmm. And then so Redis default is one of them. OK, I know I'm using Redis. That must be the ops guy must have created it for me, so I just use that. That's one easy way where you don't expose and cross the tenancy boundaries, but yet give users a very easy way to query that and then put that in their compositions and all that. Now, if I were to put some junk thing here and all that, I could always say that if this label is not present, I'm not going to even run the container. Of course, an authenticated user can only do that, but I'm not going to run this container. I'll just spin back saying terminate this before even it starts. So you could do those kind of things, provided that you always mandate certain labels to be present. And labels is a pretty flexible mechanism to tag the applications with various things. But here you're deciding as to what policy domain this tier in an application composition belongs to.
Make sense?
Okay.
All right. If there
Any
are no more
questions?
questions, then let's give a round of applause to Vipin.
Oh, wait.
We're almost out of time, unless you have some more
out of time?
demo. Yes, I think we started a little late, so
Oh,
if you have something
Sorry,
more.
guys. I'll catch up with you on the how it works behind the scenes.
Yeah, stick around,
yes,
stay back, and we're going to get Shannon set up. Feel free to actually, jump in and ask,
Okay.
bother Vipin with any questions that he has.
Sure. All right. Thanks, everyone.
Thank you. All right, while that's getting set up, I briefly wanted to use this time to talk about a couple of things. One of the things that we had set up before was we actually in the last meetup we talked about having a developer community to hack on open source projects. I wanted to take a couple of minutes to talk about that stuff. I think please go ahead and take a look at Project Contiv as well online, because we want more developers to engage with these projects. And at this point, I think there are already quite a few committers that are joining Project Contiv as contributors, as core contributors. If you are interested, or if your teams are interested in contributing into this open source project, please reach out to Vipin. Stick around for a little bit. And what we plan to do is we plan to host regular periodic events where we actually bring in mentors like Vipin himself, and from other communities as well, from Docker, from Mesos, and have them connect with devs who are interested, who want to know exactly how to get started contributing into open source. How do I just make a plugin for this, or how do I extend this feature? Because that's really important part of this community. We want to get more developers engaged with some of the open source projects. So feel free to reach out, and either to me or to Vipin and most of us folks. I think there's Bhargav at the back as well. We've been putting our heads together. We've actually managed to get a few volunteers. We have Sumant at the back as well. So reach out to any one of us. Come and talk to us, because we're trying to put together an initiative on trying to get more devs involved. So thank you. All right.
Am I ready to go?
Yes. OK. So you're all set up. So next up,
Good to go. Okay.
we have Shannon Williams from Rancher. Please put your hands together for Shannon.
Hi, everyone. Can everybody hear me OK? Yeah. All right. It's great to be here. Great to see so many people. Thank you for inviting me today. Happy to be here and talk a little bit about policy management and what we're seeing as users starting to put containers into production. Just real quick introduction. I'm Shannon Williams. I'm one of the founders over at Rancher Labs. We are about an 18-month-old startup working on building an open source container management platform called Rancher. And over the last 18 months, we've been working with initially a pretty small group of alpha users that were participating in the Rancher Alpha. Last June, we introduced Rancher Beta at DockerCon, and just almost overnight, it kind of exploded into thousands and hundreds of thousands of downloads, and we had 2,500 companies in the beta. So we've had a really interesting 9 months to work with a lot of really big companies on how they're actually taking containers into production, from government agencies to people like Sony and Amex and Disney, and one of the things we've seen in that time is that the real drivers for containers tend to be pretty consistent. Like, I think a lot of people think that we talk about all these different use cases, and there's almost as many use cases you can imagine for containers. But if you sort of dive into it, the what, why, and how is almost always pretty similar. So I pulled just some examples from a few projects we've been working on lately to kind of look at this and then kind of step back and think about what the requirements are from a policy management and enterprise discussion, and hopefully we'll get a chance to dive into this. And if we have some time, I'm happy to show you a quick demo and kind of walk through some of the stuff that we're doing. But this is a project we're doing in the UK with a large e-commerce and physical store organization, and they introduced containers basically almost for the classic use case. They were rebuilding all of their web services as microservices. They were looking at containers as a way to standardize how they deploy the applications. And the whole point of this was to be able to write once, test locally, run on their internal dev systems, point to Amazon, deploy to Amazon for the next generation production microservices, but potentially connect these between environments. And when you talk to them about this, the whole piece, over and over, they would say, look, this is our agile project. It's really, containers are just part of it. This is about continuous delivery and agile. We're just trying to accelerate our speed of innovation, speed of getting code out to the site. And oddly enough, we had a similar project with one of the top 10, 15 biggest banks in the world, and it was a really almost the exact opposite type of use case. These guys were dealing with the risk and finance applications that they use to provide data back to auditors, and it was all Java apps, running on Oracle. There wasn't a sign of cloud in this. It was just running on VMware and bare metal. And so we were kind of surprised. They reached out. They're like, "Hey, we're using Rancher. We wanted to, have you guys come in and talk to us." And like, "Well, what are you doing? And this is not normal for us." And when we got down to it, like what they were doing was they were basically using Docker, using containers to build all their test environments. They had to run something like 30 test environments to test all the permutations of these Java applications. And so they were basically rewriting all their test infrastructure in containers and using that to accelerate how they tested their services. And their point was just, look, it takes us ages to get releases out. We have to somehow compress these cycles down. If we can test faster, if we can use containers to standardize our application build outs, if we can build on laptops quicker, we'll be able to push out features more quickly to this platform because we're getting killed right now. It takes us too long to get through things. So totally legacy application, all VMware environment, and again, containers. The last one is a big national healthcare organization, and they're sort of a state body that delivers healthcare to everybody in the country. And they were looking again at more of a DevOps use case, but for them, all physical infrastructure. They were doing not really microservices. They were sort of moving to this more stateless application, but sort of a microservices architecture, though a lot less services in their model. But again, containers became how they were looking to accelerate the development process, and their goal was getting every developer to have a full dev, test, build environment on their laptop, push to Git, push to then automate the testing process, and eventually push all the way live into production. So accelerating the pipeline to accelerate features going into this service for citizens to manage and monitor their healthcare services. So really, across the board, these are not innovative companies by and large. We're talking about big banks, big government agencies, people with brick and mortar retail shops. But the containers in production movement, this is in the last 9 months, we're seeing it almost everywhere. So I think it's pretty safe to say at this point, we're kind of past the point where people are sort of looking at this with disbelief. And almost all the time when we're brought in, there's a team that's using containers, and they've found Rancher online, and they've spun it up, and they've got 20 people deploying and managing their environment. And the reasons are one of two things. It's always either they want to move faster, get this stuff out quicker, improve sort of the speed and reliability of development software, or, and this is definitely the second, much less frequently, they want to move to a better operations model. They're interested in being able to deploy to different clouds, to deploy to different infrastructure stacks more easily. They're looking at improving density because they want to move towards more bare metal deployments and leverage containers to get better density of some workload. But that's 10%. 90% is the first use case. That's what's driving almost all of the containerized applications. And it's not surprising, when we think about the software development pipeline, the impact of containers kind of goes from top to bottom. Whether you're talking about the actual person working on their laptop to, develop, deploy all the latest tools, get access to, fully implemented services that they can spin up locally and connect into whatever they're doing. You see a lot of work happening just at the developer level, but, all the way through, whether it's having cleaner build environments, or it's about sort of this immutable infrastructure and defining exactly what goes into a container consistently, deploying it every time, or it's moving into spinning up tests that are identical to what's running in production. Containers there's value across this pipeline, which is why I think we're seeing such rapid adoption of this technology. I mean, we're 3 years old. The number of companies that are deploying this is massive, and the number of meetups about it is massive, and the number of people. We have a monthly online meetup, and we're now getting 500, 600, 700 people every month coming, just trying to and we can't even get off honestly, we can't get off the internet. We're on for sometimes 2 hours answering questions as people are just trying to figure out, how do I do this? How do I run this stuff in production? So it's all awesome. Containers are great. Containers are amazing. Everyone's going to use them. And it almost always looks something like this when we kind of get to the bottom of why are we doing this? People start with, I'm going to run this on my laptop. It's amazing. I'm going to do it there. Then pretty quickly someone says, hey, great, let's create a registry. That would make it really easy for us to share these things. So we'll spin up Docker registry. That's easy. Now let's not just run them on a laptop. Let's start running them in our dev lab, test lab, production. We see it all. And no big deal. We just need to automate this. But we already know how to automate things. So we've got Ansible. We've got Puppet. We've got Chef. We've got Bash. We're going to sort of automate spinning up these containers. It's not that big a deal. They're pretty easy to spin up. Pretty quickly people want to connect them across multiple systems. So you deal with, let's introduce networking between containers. That leads to let's just build a cluster. Let's figure out how to monitor this stuff. And you can see how you sort of go through a slow and steady progression over and over. And that eventually leads to, man, we should probably put in place Kubernetes, or we need to have Swarm or Mesos or something to manage a cluster of hosts that we're running lots of different workloads on. And that's, this is our team's new Swarm cluster. This is our team's new Kubernetes environment. And that's great, and it works almost always. People are pretty happy until something breaks, of course, but they're happy along the way, and this is sort of the technology is coming along. You can sort of see how things are connecting to each other. But there's almost always at some point someone asking, okay, well, who owns this? Who's responsible for this? Who can actually access it? The kind of policy questions of, or how do we audit it? How do I know what's running? And then imagine this in organizations where it's happening over and over and over again across teams, almost globally, almost consistently. It's the risk and finance team in one department, it's the IT organization somewhere else, it's a web development team somewhere else, and you have, before you know it, dozens of swarms, dozens of deployments, dozens of clusters that are being spun up to manage containers. And pretty quickly you run into this question of, well, what are we going to do? How are we going to actually implement this? And we ran into this, I think, a lot, where people just say, we want to deliver containers as a service to our users, or we want a container service, or we want a container cloud. I mean, I think the name is almost irrelevant. Everyone's talking about the same thing. They want to deliver some type of a layer that allows the really excited team that's found containers and sees the potential and how they can accelerate their development process to empower them, but then somehow connect back to an organization that needs to have visibility, controls, policy management, some type of access control policies around deploying containers and managing them and managing the resources they're running on. So this is the challenge we sort of find ourselves constantly dealing with for users, is how do we implement something that is easy enough to use, flexible enough so that we can sort of support the different whims and requirements of a large-scale organization. Early last month, there was an article in the Wall Street Journal where Goldman Sachs talked about fundamentally this problem, and the CIO of Goldman Sachs was saying, look, we have teams that love Kubernetes and Swarm, but we can't really tell them any more than we can tell them which database to use for their application, that they should only approach containers with one piece of technology. Our whole point in the last 5 years of moving to Agile, moving to DevOps, was to try and free people up to choose to use the technology that's right for the project they're using. Anyone here who's used Kubernetes or Swarm will pretty quickly tell you they're as dissimilar as two competitive tools could ever possibly be. I mean, they really are not very similar at all. And Mesos is a whole nother bag of not similar to these things. So trying to say that, well, we should just standardize on one thing doesn't really happen. It doesn't happen anywhere. And so you end up with clusters of clusters with very disparate, broken approach to what people can do and manage. So what we've addressed and tried to solve with Rancher, and what we've heard from a lot of customers, is this need for effectively a private container service, a new type of corporate service that users can get accounts on, that allow them to consume basically infrastructure from anywhere, from their corporate data centers, from VMware, from a private cloud, a public cloud, consume those Linux hosts, take them, deploy, and build on demand the clusters they need, deploy their applications, and have some central service that allows them to deploy and manage containerized applications. And this concept of a container service isn't really fundamentally, I don't think, all that different than what people have been trying to do. If you listen to the Ubers or the Yelps or the people who, like BBC, that have been using containers now for a couple years, and we've worked with a lot of these guys, if you look at what they sort of had to do to put containers into production, it was basically, an entire stack of technology that had to be, at the beginning, developed, later implemented and integrated to solve everything from, how they were going to do storage and networking for the containers, up through, managing the actual engine, defining security for the applications, configuring this to work with their access control policies, picking scheduling and monitoring and orchestration tools, and eventually rolling it out into some kind of an application deployment framework that people could access and deploy from. So all of this was the requirements we were seeing when we were in our alpha phase at the beginning of last year, as people were just saying, like, look, this is what we have to do. We have to pick and choose some path to, kind of choose these components, integrate them, maintain them, and manage them. And that fundamentally, with Rancher, what we tried to do was build and implement initially with the beta with just one path through. It was like, okay, if we can build an integrated solution here where you can spin this up very easily, get a full stack, that would, as an open source tool, be really useful for people. And so that's what we did to begin with. We looked at how to leverage Docker, how to leverage IPsec-based networking, how to do things with Compose, and build a fully integrated stack of services. But over the course of 9 months of working with companies, what we found was sort of the same thing that Goldman found, was that it wasn't enough to just solve this in one way. You actually needed to solve it one way and then make it pluggable enough for people to deploy different type of services and configure controls and manage that across the stack. So that's really what we've been working on. So fundamentally, at its core, Rancher is a private container service platform. It basically consumes infrastructure from anywhere in the form of virtual or physical machines running Linux, and allows you to pool them into environments or clusters, an unlimited number of these clusters. And each cluster has an isolated set of networking and storage services, as well as an orchestration layer. So you can have a Swarm cluster or a Kubernetes cluster. But importantly, it connects into your systems and policies so that you can define your access controls by cluster. Say, John and the development group can access this, but they're only, allowed to manage containers. They can't touch infrastructure. And, this team over here can spin up a cluster, but they're, only allowed to run it in a certain cloud. And so you define policies and rules for what people are allowed to do. And then, over time, on top of this, what developed was the need for, the kind of controls to say, well, what are you allowed to deploy in here? What systems can you provision? Is it open, or do you need to say you can actually only provision this set of services? And the list of access control requirements is honestly as long as my arm. And I think over the next few quarters, months, you'll see more and more requirements from users to specify down to, the kind of level that Contiv deals with, which is, exactly what this container is allowed to talk to, how is it allowed to do that, how are you allowed to define, who can launch it, what it can do. So I think we're really heading in the direction where containers, their policies, the environments they're allowed to run in, the networks they can persist on, it's all going to be defined through very simple YAML-based infrastructure commands. So I'll jump into that in a little bit. But one of the interesting things we found was about maybe 3 months ago, the team at Sony PlayStation approached us, and they're like, look, we're using this catalog function that was sort of designed to make it easy to deploy applications, but we've actually built this is our control plane, so that our entire CI process becomes the policy that has to be gone through in order for applications to be approved, to sit in the catalog, and then only specific users can deploy it. And I think the demand for controls and for methods to say, these are the authorized applications, these are the authorized containers, have really emerged now that we're running not just one production application, but seeing a lot of services that are migrating to microservices and containers in production. So I think if I've got a few more minutes, I'd love to jump into a demo and kind of show you what this stuff looks like, answer any questions, of course, as we're going. But I always think it's easier to show sometimes than to explain what I'm talking about. So Rancher is open source. Anyone can download it. It's on GitHub. The way you set up Rancher is you simply deploy it initially as a container. We just last month released version 1, so we're no longer a beta program. And when you deploy Rancher, you can really just launch it as a container. You just do a Docker run of the Rancher server on any host, behind the firewall, in the cloud, wherever it makes sense. And once you bring that up, you can tell the system to create an HA cluster by putting it across multiple hosts, and it will handle scheduling itself and deploying itself in a cluster with, for resiliency, up to 3 to 5 nodes. But that service, once it's in place, looks something like this. This is this environment running in Google's cloud. And I've connected this service with GitHub for authentication. But usually you plug it into your AD or LDAP policies so that users register with their normal credentials. When a user logs in, they're immediately taken to kind of their home cluster or their default environment. Environments that I have visibility into all the environments I have access to. So an environment is a cluster. You can see I've got 4 environments in this lab. I've got my lab, I've got a Kubernetes environment, I've got a continuous delivery environment, and a swarm environment. And when you go to create an environment, you start to get the idea for how policies start to work. So as a user, I come in and say, I'd like to get a Kubernetes environment, for instance. I can then give it some kind of a name. We'll call this our Meetup Kubernetes environment. And the next thing we'll do is you authorize who is going to have access to this new cluster. So you can set that as teams. I can invite my whole team. And you can set specific policies. So we've got a handful of roles now that are range from fully locked down read-only to I own the whole thing and I can do whatever I want, or restricted, which means I can only access containers. I can't touch the infrastructure. And there's a handful more that are coming out. But you can authorize users, authorize teams, and then create environments. And initially, an environment, when you spin it up, let's go into our Meetup environment here, it's basically just a namespace. It says, OK, I'm going to create a Kubernetes cluster, but of course, I don't have any hosts. I don't have any resources in this cluster. So next, you'll come in and say, well, I'd like to add some capacity. And we work with a ton of Docker technology. So this is using Docker Machine. You can basically call out to any cloud that you have credentials on to go and spin up some hosts. Also, you can talk to vSphere. You can talk to, there's Docker machine drivers for just about anything, OpenStack, CloudStack, different types of resource managers. But if you're not using any of those, you can just deploy the Rancher agent on a host. And as soon as you have one host, we'll start the process of building out, in this case, a Kubernetes environment or a swarm environment, eventually a Mesos environment when we add that as a scheduler. And it's pretty straightforward. I'll just go into DigitalOcean because I have a credential in DigitalOcean. You just say I want 3 hosts. I'd like to call them Meetup 1, 2, and 3. And here's my credential. I copy it. Maybe not. Go in here. Everyone close your eyes. I'm going to have to change this later. OK, quick. All right, got it.
So you can always go and grab.
Oh no, I'm really gonna have to change it.
Whenever you like.
I'll know, guys. I'll know who used it. So now I'm gonna pick, what OS I want. It doesn't matter. You can use any Linux OS that's got a reasonably new version of Docker on it. And in this case, I'm gonna put it in San Francisco, and we'll start this process of launching a service. No, please don't remember that. And you can see now the next step. Once these, it's gonna take 3 to 5 minutes for DigitalOcean to come back to us with some hosts. We'll go in and create the Kubernetes master, etcd, set up all of the nodes with proxies and kubelets to build out a Kubernetes environment. And now we'll have a new Meetup Kubernetes environment that we can access. And I'll jump into that in a minute. In the meantime, I've got one running, so in case, of course, DigitalOcean fails and we don't have any machines. The whole idea is that centrally, I'll have a set of hosts, and I'll be able to have sort of visibility into what's running on these systems. So here you can see I've deployed 3 machines in DigitalOcean as well. I have some information about what's actually available in these machines, how much capacity they have, as well as any containers that were running on them. If I've added an existing environment, I'd see some containers. This is also a Kubernetes environment, so you can see that Kubernetes itself, the system was brought up. I can look at individual containers and view things like the log or access the shell. So I have sort of global visibility into the hosts, the containers, the performance of the system. You can sort of drill down into what's actually happening here on an individual host and look at any containers that are running in there, what their capacity looks like. But most of the work will get done sort of at this level. You can see this is my Kubernetes cluster that's actually been deployed. In this case, I'm running a number of containers. I think it's 13 containers to spring up Kubernetes, to deploy etcd, to deploy my kubelets and proxies. And this is effectively the infrastructure running Kubernetes. And again, if I need to troubleshoot and understand what's going on, I can sort of pull in here, kind of drill into my individual containers and scale them up or do anything else I need to manage an environment. The real use, though, happens sort of at the Kubernetes tab level, where I can now manage and actually access the kube control for this cluster I've created. Again, because we've tied this into the access control, it knows that I'm Shannon, and I can generate a credential to log in and access this actual Kubernetes environment. I can also come and deploy pods, manage my Kubernetes pods, drill into them to see the actual containers that are running in individual applications. Here you can see I've got a little RabbitMQ environment deployed, replication controllers, services, and all of this Kubernetes environment also has a catalog that I can put in front of it to allow me to spin up entire applications that are shared. And this is our community catalog, and we just introduced Kubernetes about a month ago, so it's just a few services that are in there now, as opposed to like Compose, where there's hundreds of services that are available. But what's really cool is that you can also deploy a private catalog. And this is what a lot of companies are doing, is they're not exposing this, they're sort of turning off the community catalogs in the public cloud. But what they're allowing their organizations to do is to expose a private catalog. And on the back end, this is just a Git repo that's housing, in the case of Kubernetes, a bunch of replication controllers and services. You can sort of see, if I look at this Kubernetes, I want to deploy, say, a Cassandra stack. I can have some variables that I might want to deploy and configure. But under the cover, what I'm running here is a replication controller, a service definition, and then we have what we call Rancher Compose, which allows us to define variable substitution and make changes to this Kubernetes environment and configure an answer set. And that would effectively allow us to come in and say, launch a Cassandra environment. And so now we're starting the process of bringing up this service, this replication controller, this pod. And for a team that's using Compose, you'd have a different set of managements. Or a team using Swarm, you'd have a different view for how you would manage your applications. Here you can see I have a second cluster that I've accessed, my other lab. In the cluster here, I've got 4 machines. In this case, we're using IPsec for the networking, so we're encrypting all the content. We can actually connect hosts across different clouds. So I've got a Google host and some DigitalOcean hosts that are making up this cluster. And in this case, I've deployed a number of applications as well. It's sort of a generic MyApp and a MongoDB. But now I'm using Compose to define these applications. If you look here, you can sort of drill in and see, what's actually in this stack, for instance. It's a Redis environment, Tomcat. I've got a connection to an external service of RDS that's part of it, and I'm running MySQL. So your environments are, each environment will have its separate set of policies for who can access it, and it can have its own catalog, it can have its own set of infrastructure, obviously, its own private network. So in this case, a lot of what's happening is you're using physical separation, different hosts with different users having access to them, and then private networks that are isolated within there to create security zones and allowing containers to talk within a security zone, but then using those natural barriers to set up controls and policy for access. And then using something like, again, the catalog, which in this case is based on Compose, but it gives me the ability to launch different services and often to access a set of private services. So that's really the concept behind something like Rancher. Let's see if our Kubernetes environment is up and running. It is. So we've spun up now 3 hosts. They're deployed. We've got our Kubernetes setup coming up right now. You can see it's all booting and launching, and you can sort of look to see that the Kubernetes system is still in the process of activating and coming online. And pretty soon we'll have a Kubernetes cluster that our team can manage and have access to. So that's the idea of an enterprise container service. Users across an organization get a privilege to create clusters. They can use whatever set of hosts and infrastructure they're authorized to from corporate policy to provision that cluster into. They can then deploy from either an open framework, or you can tighten it down to say, no, you can only deploy from this set of applications that are sitting in a private Git repo, which is my catalog. So you can see here, if I go back into my dev lab, where I've actually got a private catalog, and see here I've got a couple items in my private catalog, and as an admin I can define that private catalog, if you kind of come in here to the settings, is really it's just a Git repo that I'm running here and connecting as a private catalog. But you can authorize this so that if you drill into one of these, what it really is a set of Compose files and policies that allow you to control what people can deploy. So
We're pretty much out of time, but sorry for interrupting. But,
no problem.
2 live demos, and both the demos worked. We had Contiv demo working and Rancher OS working. Please give it up. I tell you, these are courageous men. When they come up here and they try and do a live demo.
To the gods of demos. So
Exactly.
It's no big deal.
Yeah. All right. So we're going to do questions, Q&As, and while the Q&A is going on, I'd like the panelists, if you don't mind, coming on up and getting set up over here. That'll be great. All right. Any questions for Shannon? All right. Please come on up to the mic and ask away. All right. If I can have you come in. Perfect.
Hey, Shannon. So I'd like to know, you talked about various customers. So has there any conversation that has changed before, like VMs and bare metal, to containers with developers versus DevOps? I mean, with operation guys. So what is the conversation that has changed?
Well, I think the starting point is the biggest thing that's changed. So with containers, compared to over the last 10 years working on private clouds and VMs and sort of implementing that service, the conversation almost always started as a central conversation. The team that was responsible for infrastructure or operations would say, like, we've got to come up with a better way to manage our infrastructure or provide services to the users. With containers, it's sort of the opposite way around. Often the last team brought in is the CIO's organization. It's really starting with the development teams. They're coming in from a very tactical perspective. It was sort of like I talked about before. They basically come in saying, hey, this is awesome. Let's start using this. And before you know it, you're kind of in a situation where you've got a lot of sprawl. You've got a lot of different teams running a lot of the same types of systems, but managing them independently. It's almost, it reminds me the most of Puppet and Chef sort of at the beginning. It was sort of like a DevOps team would identify it early on as, wow, this could be useful for us. Why don't we start using this to manage our deployments? And then, that would happen over and over and over and over again inside of an organization until eventually people said, maybe we should start trying to consolidate this. Though in that case, it really never happened. You never really saw a ton of consolidation of those pieces.
Hey, there's one more question coming up right there.
Does the Rancher know the resources? Can you bind different services, or sorry, not the services, but the deployment of nodes to specific network network interfaces? So say if you have public and local network.
Yeah, absolutely. Yeah, you can, when you deploy your containers, you can attach them to, you obviously have the normal, exposure ports where you could say, expose this on a private or public side, but you can also choose whether you want it on the managed network or you want it to run on the guest or the local network running on the actual host. So you can run on the host, the bridge, the managed sort of virtual network that's running in the environment. Is that your question?
It is, but I couldn't find it.
It's under the advanced tab, and you kind of go to, I'll show you later. Come by.
That's where the good stuff's at.
The
All right.
hidden tab.
Perfect. All right. So we have one more question. All right. We'll go ahead and have that last question, and then we'll wrap it up.
That's again for you. Sorry, guys. So you mentioned, in one of your slides, you mentioned 3 different customers.
Yeah.
3 different types of customers. When you talk to them, right, what do they usually, are they ready to move? The first question is like, are they ready to jump into the containers world? Especially the banks who are, they want complete, full, mature stack. They won't use the latest and greatest. Like you mentioned, they are not the most innovating companies. The second question is...
Hey man, don't go around stealing all of Samir's questions over here. We have a moderator here, but I'll restrict it to the first question if you don't mind. In the interest of time, stick around and ask all of your questions. We'll have some time after, but I'll let Shannon take this one.
Yeah, sure. I think it's it's funny. I would say it depends on the company, like you'd imagine, but there is totally a movement towards big companies doing a lot more innovative stuff than I ever remember from 10 years ago. Like I would say, I think it happens almost all the time that we find teams that are, like I was mentioning, Amex is a good example where you think very, kind of old school organization, but doing a lot of really innovative stuff with containers. ING doing a lot of really innovative stuff with containers. So yeah, I was surprised. Like of the first 4 or 5 companies that I saw out in the world sort of talking about how they were using Rancher before I knew they were using Rancher, one was like an insurance company in Australia, one was Saks Fifth Avenue. I mean, it was things like that. It's like, who would imagine that would be the first people out using the NHS in the UK was really publicly sitting out there saying, we're using this. And this was when we were in like maybe 3 months into beta. And they're talking about production workloads like for Christmas at Saks Fifth Avenue running on this stuff. And I was like, well, I'm glad you're confident. So, yeah, it's a brave new world. People are moving, they test it, they try it, they go through their chaos monkey, we're comfortable with the design, and then they go. And so it's, you build an open source product, you kind of have to be prepared for that. And it's certainly what we've seen.
All right, that's awesome. Okay, so let's move on to our next part of our session, the most interesting part. We have our panel here that's going to talk about policies and how it applies to in a containerized world. Let me start. You've already heard Shannon Williams from Rancher. He just spoke previously. He's agreed to be our panelist. Thank you so much. We have PJ from Illumio. Thanks, PJ. You've also heard from Vipin. Thanks, Vipin, for standing in. Appreciate it. And we have Samir from StackRox as our moderator. All right, gentlemen, with no further ado, I'll let you take it over.
All right, let's jump in. Everyone hear me? Grab a beer outside if you're thirsty. There's plenty out there. All right. I know a lot of people want to know if people are really using containers in production, right? You mentioned the path that a company goes through to get to production. What fraction of the companies you guys talk to are actually running containers in production today? Why don't we start with Shannon?
Fraction?
Just take a guess.
Maybe 25 to 30%. So,
not bad.
I mean, obviously, we're talking to a lot of people using containers, so we're biased.
Right.
Maybe even higher, maybe 40%. It's pretty consistent. The big difference between who's using it in production and who's not tends to be the workload. So, if a company is using it for something like I mentioned, the risk and finance group of a big bank, they're a lot more likely to be using it in test and dev than they will be to putting it in production. But if it was the web division doing some type of of an online type of program, I think it really mirrors cloud. Like if you think of the adoption rate of production applications running in Amazon, you probably are seeing a very similar model.
Gotcha. How about you, PJ? What do you see?
I mean, so a lot of Illumio's customers are large enterprises, similar. I mean, we have Morgan Stanley and Salesforce and other customers like that. I think where we come in from a security perspective, right? So it's not the DevOps side. We come in with the CISO, and the CISO is one who's is the one who sort of say, how can I secure these things? Right? So we do see some movement in the kind of the same ways, right? In dev and test, and when they get into production, they have to know how am I going to actually secure that? And so those are the questions we sort of get and sort of see.
Gotcha. How about Vipin?
Yeah, not many. I mean, not definitely 25%. I would say that probably 3 to 5%. And my take is mostly about production is really putting things out. So web class of app users are very primed to take it into production almost right away. But if you talk about classic enterprises trying to move into, and this is about enterprise and microservices. So their applications sometimes are not ready themselves. So microservices is a long shot for many. But people who are starting up fresh and starting those things, they are more ripe to get into production right away, mainly because they're writing their applications that way. So I would say, test dev very high. It has picked up in the last 6 to 9 months, quite heavy. But not that many in production, I would say.
Gotcha. 3, 4, 5%, 25, 30, 40%. Wow, big difference here. Let's stay with you. So the topic of the event is policies, right? So big picture, what are the companies worried about? Why do they want to set policies? Is it because they always have before, they think they should now? Is it because it's kind of chaos, everyone's doing everything and they want to control it? Is it because of security concerns, they want to limit who can do what? What's the main reason they're thinking, I need to set policies, I need some technology to help me?
I mean, security is definitely at the top, if you look at it. Security is one reason. Second is ability to know what's going on, audit, compliance. That is another reason. Then the third thing is that, you want to be able to also keep the whole, is this on?
Yeah.
Oh, okay, okay.
Thank you.
Oh, okay. So also keep track of everything which is happening and knowing where the resources are. Ability to monitor what's going on is the foremost important part. Before you say that, oh, I'm containerized and all that, maybe your promise was that you will get, 60% more utilization. Are you getting that or not?
Right.
So in order to, and who's using how much, if you don't know that, then, if you do, once you know that, you can say that, oh no, this user is not supposed to be using 80% of my resources.
Right.
And then, you go from there. So it's mostly about knowing what's being done towards the tail end. The top reasons are definitely security, compliance, and then trying to make the resource utilization in a predictable manner.
Gotcha. So PJ, I know you're going to say security. Tell me about security versus compliance, perhaps, and if you want to drill down on what specifically people are worried about today.
Well, I think I wanted to follow up on some of what he was saying. I mean, the one thing is, it is around risk reduction, right? It is around minimizing, but what people have to do first is they really have to understand what's happening inside these environments. So there is this concept of before you can even build or author a policy, being able to provide that visibility and understanding of what's actually going on. And once you can sort of do that, that's where the monitoring comes in, right? There is allowing something to occur and seeing it and necessarily alerting on it, and then there's the next phase of actually doing the enforcement.
Right.
So there's this whole kind of transition that you have to go through to be able to sort of author policies and sort of finally lock them down. The one interesting thing about containerized environments is there's actually a lot more metadata that is there from the get-go, right? That these policy engines can sort of hook into and both visualize and enforce. So that's kind of an interesting sort of movement with containerized environments.
And just to follow on one thing, what's the difference between security and compliance issues here? People use different vocabulary. Sometimes different people will approach you in a bank, right, with that job. Is it all the same thing under the hood, or are they different?
It depends who, it depends what their job is, right?
Right. Let's take a PCI compliance person in a bank, right? As an example.
So there are certain kind of regulations that are sort of involved in compliance. So for us, it's about either attack surface reduction or segmentation and compartmentalization of the network. And those are used for both those purposes. Just how you come about them, who is involved, what is the business driver, right? There's always the compliance driver, which is a regulatory requirement, and then there is the CISO who's coming from a pure security point of view and still wants to improve those environments from a security perspective.
Gotcha. Hey Shannon, how about you? Same question here. What are people worried about?
It's
and you're seeing a lot in production, so.
Yeah, so what we're not specifically a security product or a compliance product, and so our approach is actually kind of the other way around. We tend to deal with the users sort of getting really excited, pushing this stuff forward, and then running into the compliance requirements, or more important, to be honest, it's more the security compliance, security requirements, and then compliance maybe as a subset of that at some point. But it tends to be, as people push the stuff in production, there's a security audit that happens, and people start to ask a lot of really good questions about, who can do what can they do, and I think right now there's still a pretty good, I would say, gap between the ideal that the security department is really desiring and what most places are at, like where most people are today with security. So, very often what we're seeing is people are, they're bringing in not just tools, but a lot of time external consultancies and people to come help them evaluate what they're doing. There's a number of new security companies that are emerging that are specifically focusing on security, both looking at what's running in the container, how do I know what the history of this container is, and obviously more access controls, more policies. And so I would say that right now the focus is much more on security than compliance per se. There's obviously compliance discussions in specific cases where you're dealing with, say, something, but I mean, quite honestly, it's very rare that we're dealing with applications that are dealing with, say, credit cards. And a PCI compliance specific thing is the first stuff going into containers. So much more often it's, I would say, a more broad general concern about security than a very specific, we have to get PCI certified on this application, and now we're putting it in containers. That's probably the last application that's going to go into containers right off the bat for most of the environments we're talking about. Gotcha. Not 100%. There certainly are people who are doing PCI compliant workloads in containers, but again, that's more of probably a place where the entire system is already in containers. And sort of Vipin's point, the web-first organizations, those are the places where you're getting PCI certified on containerized applications.
Makes sense. So Shannon, in your talk, you mentioned orchestrators, right? They're all different.
Yeah.
Kube and Mesos and Swarm. How do they play out when you're trying to enforce policies in the system, right? Which ones are strong, which ones are weak? I'd love any comments about what's good and bad about each of the orchestrators. I get a lot of questions about which orchestrator to pick, right, for a given system. Maybe you can shed some light on which you'd pick to do policy well.
I think, which would I pick? The thing about comparing Kubernetes and Swarm, I'll talk more about those two because I think those are the ones that are most commonly being picked for containers. Mesos comes up and certainly is used in a number of large organizations, but it's probably a distant third right now in terms of the number of projects going on. And Swarm is what we see in Swarm is a lot of deployments that are very Docker-centric. People who come from a Docker background really love Compose. I think a lot of times Compose drives adoption of Swarm. Certainly for us, we're big Compose fans. We think Compose is just a really nice framework for defining application stacks and then deploying it. So I think for people that are deploying Swarm, what they run into pretty quickly is it's pretty early. I mean, Swarm is still pretty early. It's not at the same level of functionality that you get in terms of high availability and service discovery and a lot of things that you can do inside of a Kubernetes environment. But it has a much lower learning curve. It's very natively intuitive to people who've been using Docker for some time. And so I think it has a lot of advantages. It also scales great. There's a lot of, because of its simplicity, it's easy to operate. I mean, setting up an etcd cluster, I did it in 3-4 minutes. Anybody who's done it, it's pretty, it's pretty time consuming. You've got to build etcd, you've got to build Kubernetes, you've got to deploy a whole bunch of pieces, manage them, manage their upgrades and stuff. So Kubernetes is a little harder to deploy, but it's really feature rich. I mean, you're talking about a platform that is being built to run very production grade applications, to handle a lot of really nice automation for failover, I think Kubernetes is just going to keep getting more and more, powerful and rich, from a feature perspective. So depending on what you're trying to do, there's pros and cons.
No, great answer. And down the road, do you think there's room for both of them? Or do you think
heck yeah. I think there's. I'm of the camp believes there's going to be lots of schedulers. So I think, schedulers. We've been writing schedulers since we started having computers. I think that there's no reason to think that we're done writing schedulers. I think Mesos is an amazingly good scheduler for certain kinds of workloads, and it will be very popular for a long time to come. I think that as we, get to a world where, we're trying to schedule based on, optimizing quality of service, optimizing price, optimizing compliance, you're going to have schedulers, continue to add functionality and capability. I think there's room for an unlimited number of schedulers.
Fascinating. I think there's some perception in the community that we're nicking down to a smaller number of orchestrators, right? Fewer number of choices for people who want to have a fewer number.
I mean, everyone would love that, right? Everyone would say, like, wouldn't it be great if we had one standard and everything was written in,
or two.
But I just don't think that's what's going to happen. I think that you're going to have, if you've used Nomad, I think that's an interesting tool. I think there's going to be, I just think there's going to be more innovation. It's open source. There's always going to be innovation. So.
PJ, how about you on orchestrators? Yeah, what do you see?
I don't necessarily have an opinion, but I do think one of the things that does slow down adoption is there's a huge amount of choice and a huge amount of options that are sort of out there in the container environment, and people don't necessarily know. This is where we run into, customers who are trying things out, and all of a sudden they're doing one thing, and then tomorrow they found something else new, and so they can't switch. That's what the beauty of open source. But in some ways, if we do kind of have, less options and more standardization, at least, or maybe there's winners that do, come out of that. That's where, acceleration can move forward. But you also made the point before that it is about cloud adoption. All these things are there is a cycle, right? And we're at a certain point in that cycle, and we'll continue to move, and there'll be winners, and there'll be people who use more, much more frequently, and that'll help speed things up.
What's your opinion on orchestrators? Pros and cons
Yeah,
when it
no,
comes to
I'll
doing
take the
policy.
policy part of question with
Yeah.
schedulers first, and then I'll talk about generally, how things are.
Please.
So if you look at Kubernetes, they have split up the, in general, I think Kubernetes is a more modular, orchestrator. So you could like replace their scheduler itself and keep the API server and keep the rest of the components, and it'll work. We have replaced a couple of components from Kubernetes, works. Everything else just works fine. So it's kind of like, you are creating a scheduler which is built on concepts of microservices on its own. So which means that now, because you build like that, you have all these APIs which are like, completely pluggable, and Kubernetes is a little bit further out, like I think what Shannon was saying, compared to Swarm, and Mesos is definitely great too. But from that point of view, from applying policies and all that, like it has interfaces for admission control. So you could, for example, say in a Kubernetes cluster, write your custom admission control to say that, I'm going to control exactly how much quotas are given for different users, and I can enforce that without touching Kubernetes at all. You just say that, you use this REST APIs, here's my code, throw it in, and you can do that enforcement for policies very easily. That thing is coming up in Swarm. I'm not saying Swarm doesn't have it. Swarm just added authorization plugins in 110, I guess, and then 111, or not 111 doesn't have it. I think auth N is coming in.
Right.
So Swarm is catching up on that front, but it is trying to embrace those concepts as well. I do think that there's definitely a room for not one, I would say 2 to maybe 3 at least. Yeah. So
Gotcha.
I mean, in general, that's a good thing because why is Swarm adding all these things? It's probably because Kubernetes has it. Why is Kubernetes going to improve? Because Swarm is going to do something else. So this level of competition is not bad for Swarm itself, Kubernetes also. So it's good for them too.
Healthy competition.
Yes.
PJ, do you have a point here?
No, it was in some ways, it's like, good old 1996 with the Linux kernel. You could sort of build whatever you wanted and put whatever, and then, the distributions came out, and, and then there was, multiple competing ones. That's kind of the life cycle of this.
Gotcha. Let me shift gears a little bit to what mistakes you're seeing in enterprises. So I know audience always loves to hear what hasn't worked, right? So that we can learn from people's experience. You don't have to name names of companies, but you're all working with some of the biggest companies around the US, right? So what are you seeing not working when it comes to policies, generally container technology here? That would be a good lesson learned from the audience. Go ahead, please.
Sure. What will not work is way too complicated stuff that you're trying to do upfront.
Keep it simple.
Keep it simple, but keep it manageable.
Yeah.
If people are trying to conquer the world with the current set of tools, it's going to be quite tricky, and it'll be a mess. So
Start simple with some network policies only, right?
No, we do storage policies too. No.
Yeah.
So my point was that was that you could do a lot more, and there is going to be requirements. I'm not denying that those requirements don't exist. My point was that start off with simple things so that you can get the ball rolling and get those things exactly what you want, as opposed to try and boil the ocean right away, which is not only not going to be possible, but the systems that you're relying upon have not been tested to that level either. So I mean, Swarm release comes out like every 2-3 months, and it's probably a 8 to 9 month old scheduler technically. I mean, production ready. So if you want to do more complicated stuff with that, and you expect that you are going to be winning that, tough luck. But will people get onto these things? Absolutely yes. It's a matter of time. Scale and those things, I'm sure that's like the touting rights, so everyone will get that. So Nomad scaled to million. I don't know how they did it, but let's say they scaled to million. And Swarm can scale to hundreds of thousands. Kubernetes can scale to. But so scale, the classic touting rights, everyone will get that right. The question really is that whether you can give the customizability and keep it still simple for other people to not worry about your internal details.
Makes sense. Keep it simple. Start at small scale.
Yeah.
PJ, what are you seeing out there?
So
Mistakes people are making?
I'll take the same security angle. So, I mean, one thing that has happened traditionally is, the CISO and the security, has come in at the end, right? The DevOps pick something up, they sort of push it through, and all of a sudden, the CISO's job is to, he has to say, he or she has to say no, right? I have to stop this from happening. So the one thing that has to change is security actually needs to move to part of the software development lifecycle, right? And Shannon, you had that nice slide up there about all the different bits of that lifecycle. if you actually enable, developers, right, application authors to sort of participate in not only resource policy but security policy, kind of early on in the cycle, when it sort of gets to that, that later in the stages, then the security team can sort of look at something that has already been authored, actually like look at it, maybe it follows even best practices, and sort of say yes at the end as opposed to having to say no and put the brakes on stuff. So that's one thing that we've done wrong for a long time as an industry. And we can if we sort of continue to think about security, throughout that life cycle.
I think that's a great point. It's always hard to say what people are doing wrong. I think the thing that I've seen now, it's not even necessarily specific to containers, though I think we're seeing it here as well, is there's this, now I think there's such a fear of picking the wrong technology that there's almost like this analysis paralysis that starts to kick in as people try to pick not which tool fits their requirements best, but what's going to win. What's the winner? We're sort of obsessed anymore with picking the winner, and the winner, if we pick the wrong one, if it works for us, but it's we'll be left on some godforsaken island where no one will ever work. But I mean, how many people are using Zen, Amazon, right? I mean, they're not left on some island where they can't. You don't have to pick the right tool if it fits your world and it works for you. Move forward. Don't hesitate. I see this all the time where companies are trying to sort of say, let's standardize. And of course, it makes sense if you're, if you think about it from a beautiful world where we're just going to have one database in a company, or we're going to have one tool that works. It's just not realistic. Pick tools. Assume that you're going to throw them out in 2 or 3 years and move forward. Stop wasting time trying to pick winners and assume that there's just going to be one thing that wins. I mean, everyone that's built, had enormous investments in OpenStack can tell you how much time they can spend picking something that's guaranteed to be the greatest thing, and then find out, it doesn't make it any easier to operate. It doesn't make it any easier to upgrade because it's sort of the de facto choice of the market. So that would be my big sort of, just across the board. We're so obsessed with picking winners that we ignore a lot of great technology out there that works for use cases.
Got it. You're saying be more like a startup. Pick something, get going.
Yeah, absolutely.
Don't wait too long. All right, another question people ask me a lot is there money in this, right? So some of us are vendors. A lot of you guys work at enterprises. A lot of the best technology we're talking about is free, right? It's totally free. It's open source, to your point. Is there money in this, right? So to the degree you're talking to companies who actually want to pay for container stuff, policies or otherwise, what do they want to pay for? Who wants to go first?
I'll go first. I'm an engineer, so No, I think I have some person from marketing side. I'll let him speak.
Someone has to pay your bills, right?
Yeah. So I mean, if there's a value, the value can come in the form of security. It can come in the form of, if I can take open source stuff and deploy it as is, it's one part. But trying to give a solution and backing it up completely is a totally different ballgame. Mm-hmm. So while I can do Docker run on my laptop and do composition and all those things, kind of things that Shannon was also talking about, and was talking about the security and all that. So keeping it together in a sane, usable way for the end user is definitely something that I don't see it free, really.
Gotcha.
So,
complete solutions and usability.
Yeah.
You think people will pay for?
Yeah.
Anybody else here?
Yeah, I mean, I'm pretty sure there's money in it, but I do think that the reality of how much money's in it is probably like everything else. It's a shrinking total pool. So we're dealing with a total shrinking IT spend that people are going to be spending on IT, and so
because IT is cheaper, or because of open source, or both?
Because there's downward pressure on spend, because server infrastructure is becoming cheaper, because open source tools are becoming better, because organizations are more comfortable using open source tools, because companies are able to push constantly on vendors to drive down costs. So I just think overall we've seen it now for, it's probably been a decade now. We've been seeing steadily decreasing total overall spend in IT, and it's why there's so much change going on in the Valley. So many companies are, changing hands, and organizations like EMC are now part of Dell. You're seeing a restructuring, and open source and commodity infrastructure are the two great waves of our generation. They are fundamentally changing, the relationship between the consumer of technology and the developer of technology. Where, we're using, I'm using technology in my product that Google built, right? And that helps me build a product that services a government agency in the UK, what's the value chain there? How do I reflect back the fact that, Kubernetes is important to me, what Docker does is important to me, and I have to deliver value? I think, there's always money. There's always companies who need support, need great services, are willing to pay for great products. That's not going to change, but there is a ever shrinking pool of dollars. It's harder and harder to get money for very specialized services. There's more pressure on vendors to build comprehensive tools and to make those tools available on pay-as-you-go models that sort of reflect actual adoption as opposed to potential adoption in organizations. So, it's the reality of building technology today. You can't come in expecting that do you think Docker is going to be worth as much as VMware ever was, right?
Right.
No, I don't think anyone believes that, right? And just for so many reasons, but the very least of which is Docker's free and
Right.
ESX was never free.
Right.
That's fundamentally changing things, and they have another challenge to go and monetize. So yeah, there's
Gotcha.
money, but it's not going to be by any means as easy.
So shrinking pie, bigger and better products will get a piece of that shrinking pie.
I think the one other place is there. It's all well and good to sort of say I can connect this many hosts to this and this orchestration system, but I think being able to operate it at scale, right? That's where you sort of have to prove, right, things, and that people that products and that can be operated at scale, right? Which actually kind of can save enterprises money as well. Is one place where they will sort of pay for. Right. True operation, at scale.
At scale, got it. All right, let me shift gears here to talk about the cloud providers. All right, another question I always get is what do you think of the container services within Amazon and Azure and Google, right? You all know about Amazon EC2 container service and Azure's container service and GKE, the Google container service. I think unclear at this moment exactly what kind of policy services they'll build for you versus what you'll still have to operate on your own. I thought I'd ask you guys to look into your crystal ball and tell me, what do you think those cloud guys are going to do, which will make it compelling on their own versus what will be left to the market to do?
Yeah, I mean, look at Amazon, right? So they have certain things. They have policies. They have structure, how you deploy VMs and all that. If I were to guess that ECES has to offer exactly same thing, because they cannot say that, VM workloads, we give you this thing, but container workloads, we don't give you this, or we give you something extra, then people are going to ask this back and forth. So they have a precedence. They have to match that. And to me, I think, they have to at least do that until this workload shift happens and people are comfortable deploying containers on bare metal and all that. I mean, VMs could always exist in all those. But
so all the old network policies, identity and auth policies, you think will be built into the container
because
services?
people have built their tooling around that.
Yep.
I mean, Amazon is not just a Amazon is not a provider of VMs anymore. It is an ecosystem. It has an APIs that you build on top of. It is a lot of things that go into it. You have built things on top of it. Now you are very comfortable with that. And what you say is that, container service, I can't give you all these things that I was giving VMs. That's not going to fly.
So you think they'll have to match that?
They have to match it. If they don't, then people are not going to adopt containers on those public clouds as fast and as easily because they are used to that.
Strong words. That's a mandate for Amazon to do it. All right. PJ, Shannon, what do you guys think?
For security, the same thing. Security is a shared responsibility model inside Amazon, right? There are certain things that they provide in the infrastructure, and then certain things that you as the user of it need to sort of provide. And what that does, it allows you to provide best of breed technologies where you need it to, and you to use the infrastructure-based services where is appropriate. So they need that slider. Right, and they have to be able to provide both those things for their customers. So I think it has to continue that way.
Shannon, and you can talk about Amazon or all the cloud companies.
I would talk about all of them. I would say what we're seeing is there's a subset of customers who really are totally committed to a cloud vendor, and in which case they're bought into that cloud vendor's service. But it's a really small minority. The vast majority of companies are seeing containers as, the first legitimate approach to dealing with cloud lock-in, with portability, with application, distribution across different services. I don't see a lot of people lining up, quickly to jump on container services from a single cloud provider and sort of throw away that big benefit by locking into more of an ecosystem around containers that is also not portable. Now, Google has the benefit of running Kubernetes that is very easy to deploy anywhere, and so you may find people very nicely will take a Kubernetes cluster from Google and manage that alongside Kubernetes clusters running elsewhere. But I'm definitely seeing in our user base, which is not surprising because it's people who don't who are choosing a different direction. But I'm definitely seeing a lot of people who are very adamantly don't want to go to a hosted container service run on a specific vendor because they just feel like there's one of the big benefits of containers is portability that they are effectively sacrificing to that. And it's not that hard. I mean, that's the thing.
Right.
Building, the when you look at spinning up a cluster, you start thinking about where this is going to be. It's not going to be difficult to build your own container service. Nothing like building a cloud. Building your own OpenStack implementation versus setting up something like Rancher that is just a few minutes. You get it deployed.
You don't need it.
It's just a different level of effort, and that's why you may not ever want to do your own infrastructure as a service.
Fancy.
But doing this stuff is pretty easy.
So on this cloud point, and then 2 more rounds of questions, and we'll open it up to the audience. Thanks for your patience here. So just on the cloud platform, not the container service, but GCP, AWS, Azure. If you're advising your enterprise customers, which cloud platform to use to build their own container system, as sophisticated as they want, which one do you pick and why? Some are better at network, some are better at I/O, whatever it is that you might be looking for. What are your preferences here? Personal opinion. Yeah, go ahead.
Cisco Cloud.
Cisco Cloud. Cisco Cloud.
I don't give opinions on that, I would say. I've yet to been asked. No one gives a crap what my opinion is about which cloud they could be like. It's almost always the same. They have a corporate mandate or they have a bunch of free Azure credits. So they're either using Amazon because they got to choose, or they're using Azure because someone else chose for them.
Okay.
Occasionally they're using Google.
Somebody else picks Cisco. Do you have an opinion on this?
I mean, back to what Shannon said a few minutes ago. I mean, people are not going to want to have the lock-in into sort of one of those environments.
Yeah, don't pick one.
Don't pick.
Good answer. All right, last round of questions, and then please step up to the mics if you have any. So the Docker engine, the Docker runtime, right? That's the middle, at the center of everything we do. Do you guys think the Docker runtime has kind of won the war to be the standard here? Or do you think that real face, like Shannon said before, lots of different options here? Certainly the companies I talk to, they're almost all picking Docker as far as runtime at the moment. I'd like to hear what you guys think, and how that factors into doing policy well.
Go for it, yeah.
Okay. So again, I go back to my healthy competition part.
Yeah.
It will not be one. I think there'll be multiple, and it's okay. I think it's good for both and everyone, for end user, for themselves, because there's competition that keeps you all kicking in life.
Right. So Docker has big market share now.
Right now,
you think that will decline a bit?
It is Docker, but you know what? If the container format is same, it doesn't matter.
Yeah. Right.
It really doesn't matter whether if tomorrow Kubernetes switches to some other runtime. How do you care if the same application is running exactly the way it was running before, except that you have to move the whole environment to a new one? Mm-hmm. So application format is the bigger one rather than what runtime it is using. And yes, every runtime will have its own set of things and all that, but it'll definitely fit into all ecosystems quite well. So
multiple options, all interoperable. That's your vision of the future.
Yeah, it won't matter to me, I think, which runtime it is. In the long run, right now it is Docker because it's a very mature thing, and we should use that because that's what is the most mature runtime available today.
Right. What do you guys think?
Yeah, I agree. I mean, I actually almost 100% agree. I think the work going on in OCI to sort of define the format is going to, has the potential to break it up more than it has the potential to standardize it on Docker. But you're 100%, it's not even 99.9. It's like, I think I've been asked about Rocket maybe 6 times in 18 months of working on this.
Yeah, same.
And in every situation, it's sort of like, okay, great, but let's go use Docker. So it's not as if there's really harsh competition going on at that level. But I don't think that there's any reason. I think what the biggest risk Docker has is the more heavy and the more they stuff into the actual runtime, the more likely you're going to see it get forked or get pushed in a different direction.
Let me just jump on this. You mentioned Rocket. So under what circumstances do you recommend Rocket? I know not too many people are asking you, but are there certain cases where it's superior, in your view?
I'm no expert on Rocket. I think that I don't recommend it anywhere. Not because it's not superior, just because, well, first because we don't support it. So I'm very self-serving. No, don't touch it. But more realistically, it's just down to
demand.
Yeah, demand. There's no demand. There's no demand for us to support it, and not enough demand to invest the effort right now to support it.
Right.
Compared to like Windows containers and stuff, where at least there's demand and people are excited about it, and so that's more for us. There's engineering demand, so we go and build that.
PJ, I'd love it if you have a security point of view. The Rocket people are always talking about security features that they built into all CoreOS products. Do you have an opinion here?
I don't have an opinion.
Okay, fair enough. Guys, I'd love to open it up to your questions. We've got a great panel of experts here. If you've got any questions, please step right up. All right, go ahead.
Quick question. So,
hey, just please introduce yourself real quick.
Yeah. I'm sorry. Ananta Ramaya from Ericsson. And quick question is that we talked about container security and everything. And also, I think Vipin mentioned about telemetry sort of thing. One of the things is the data analytics and stuff, and also machine learning, where people are really talking about I can go to the extent of doing this, detecting zero-day attacks and stuff like that. I mean, when I was having a brief stint at NTT, that was one of their pain points as well. So I'm trying to see how is this playing out, and do you guys see in this containerization, etc., all this data analytics and also to some extent machine learning, are these kind of becoming popular? Or, I mean, I don't ask a question like how much fraction or percentage, but curious to get your viewpoints.
Got it. So just make sure the question sounds like in the container world, are there opportunities for data analytics and machine learning, perhaps to catch 0 days or anything else? I think the answer would be yes, but let me let you guys jump in.
Yeah, I mean, if you look at containers maturing, they are not even teenagers, I would say. Forget being adults and all that. So we are looking at people being happy that they can deploy container applications in a 100-node cluster, for example, and they are happy with that. Machine learning and some of the advanced things are. I'm not saying there's no room for it, but I don't think the audience is willing to consume it at this point. There's definitely opportunities there. But people, I mean, networking came last November,
Yeah, exactly.
6 months ago, which is really more than one host. So we are talking about a stage which is way too early. People are happy to containers talking across two hosts, and trying to talk about the advanced concepts is needed. That discussion should happen now, but I don't think consumers are ready to take that today.
I mean, I think the other part about it, and I said this before, is there's actually a lot more metadata, right, that's involved in these container environments, which means you don't have to guess at certain things, where in traditional environments you actually had to apply machine learning techniques because you had no ability to understand what the application is or what the processes are running. Once you actually have more data and more information, you still are doing analytics, but it's less about those machine learning algorithms and more about kind of traditional data visualizations and data analytics that you're sort of providing. But people do need those kind of things.
There's a mic right there. Yeah.
Just in answer to that question, there was a very interesting talk by, I think, a fellow from Brocade, David Meyer, if I remember correctly, at the DevOps ONS Summit. It was on machine learning applications, so just FYI.
Okay.
Thanks.
Swarna, right there. Okay.
Hi, Swarna from Avi Networks. Had a quick question for all three of you. When you asked the question about the percentage for the containers in production,
right,
I was not really surprised by the disparity in the answers, but would love to kind of see where the answers are coming from. So what are the profiles of the organizations that you've seen that are deploying containers in production versus dev and test? And specifically for PJ, what type of organizations are more focused on implementing security in a container environment?
Shannon, you're in production, right? You have the 40% of companies in production, right? So
Well,
what are the patterns there?
I'll tell you,
with the ones?
again, when I talked about 25 to 40, these are of our deployments and users. So, I didn't mean 40% of all companies have containers in production. I should have been more clear. Of the people that I see using containers, I think I see, 25 to 40% that are putting, and it's probably just what you'd imagine. I think it's really high percentage on the startups, web companies, e-commerce companies, mobile apps, web app, people that are, pushing out web content and effectively delivering some type of web services to users, hosting companies, all sorts of things like that. And it's much lower when you get into, but in the enterprise, I would say I'm incredibly positive on the number, that we see, lots of deployment productions. Deployment implementations of internal services, deployment implementations of customer-facing applications. It's much more popular, I would say, with web services, obviously, for things to be in production than, say, databases or anything on the back end. But it spreads the rest.
How about geographically? Is it U.S. focused or is it really worldwide? You mentioned some UK companies.
Yeah, I would say it's, if anything, I would say it's a little bit more. I think we've jumped the point where technology emanates from here and we then see the world adopt it. This stuff is happening equally everywhere. In some respects, I would say, you're almost seeing generational skips. Like we have a ton of business in China. I would think, in the last quarter was our biggest market, and it's insurance companies, it's telcos, it's airlines. Australia, there's a lot going on. There's a ton going on. So I don't see any geographical split. I mean, no, zero.
And among the regulated companies, you mentioned regulations before. Are they having trouble getting through the regulatory, checkbox for these new container systems? You're not seeing
Go
it?
ahead, PJ.
I think it depends what the application is. I mean, a large regulated environment, a large regulated enterprise has a whole slew of different kind of applications they sort of, deliver to highly regulated ones that are PCI environment ones to, less regulated applications where they can actually experiment and kind of use these, container environments a little more liberally, right?
And are you seeing the highly regulated parts actually in production yet, or we're not there yet?
I mean, I haven't seen that.
Yeah, I would say no. I mean, like the highly regulated, I was mentioning like big bank risk and compliance. Like,
and you mentioned
again,
healthcare too?
It's on the dev and test side of these applications more likely than it is on the production systems. But I am seeing it on very traditional apps.
I mean, the other thing that I've seen is, so there is a microservices architecture, and then there is the use of containers, sort of like replacement for VMs, right? That they're not short-lived. They're not short-lived. They're not auto-scaling.
Right.
This is a container, and it's to still speed application development, but it kind of lives like a VM, right? And in those environments, they can still sort of make their way into those kind of regulated environments.
Gotcha. And Vipin, you mentioned only a few % in production. Were there any patterns there?
Maybe I was. It was not the percentage of customers I'm talking to are in production. I was talking about the percentage of customers that largely I see going into production. And production as in literally running production applications now.
Gotcha.
And so that was one clarification to what you were saying. I was also not talking about the Spotify of the world and that kind of people. They are going to do whatever they are going to do, right? And I was more talking about enterprise customers and maybe service providers to some degree, but definitely not born in cloud type of application owners. So with that, I would say that it is the percentage that I talked about. Any
Gotcha. No, that sounds good. Thank you very much. I think we have time for one last question, maybe, before they close the videotaping. All right. Last but not least.
Yeah. Hey, I'm Vinay, and I'm an engineer at Nuage Networks.
Great.
And my question's more, it's kind of related to the scale at which containers are deployed when compared with VMs. And just given the fact that you guys are talking to real customers with containers in production, what are the telemetry requirements that these guys are coming up with as far as audits and tracking containers and information about these containers are concerned?
All right. What are the top telemetry requirements for your customers who are in production?
So one thing is, one thing that I see is to be able to deliver policy. If you think about think about the three V's of big data, right? Velocity, volume, and variability, right? Being able to deliver policy at scale, or either absorb telemetry or deliver policy at scale, is a big data problem, right? The velocity of container creation and the volume that is different beyond VMs. Those are the two scale issues that really have to be addressed whenever you're sort of thinking about those problems. So I don't know the specific telemetry requirements, right? For me it's about understanding networks and applications and and processes and so on. But the amount of data that's coming in and how fast it's coming in terms of being processed and stored, is a huge sort of problem and a huge scale challenge that sort of we have to solve. I think that's the bigger problem than necessarily the type. If you build, if you have such an engine to be able to ingest that, you can put other types of data in there that rather easily. But it's the scale problem that's the first thing to challenge. The first challenge to sort of address.
Anything else here?
So
okay.
I'll go with microservices architecture was built to scale out, right? Why not use the same architecture to get the data as well? So don't centralize it, distribute it, collect it on wherever it's needed, then trickle it up. So if we go and use and drink our own, Kool-Aid or eat our own dog food or whatever you want to term it, if we do that, then yes, microservices-based architectures are meant to scale out and are meant to deal with the scale that people are running quite successfully for 10, 15 years now. So it's not even like a question. We are trying to embrace that technology now that some people have been running it for 10 years now, let's say, right? So it's proven model, it's working, it works. Let's not try to fall into and look at it from the lens that we are used to looking at it. It's like, how do I deal with scale? Well, don't centralize it. Don't keep these things in a way that you used to, because that didn't work so far. And if you try to do 3 V's that he was talking about, velocity, increase, and all this, volume, you're not going to be able to deal with it if you don't embrace that, that engineering-wise, I think design-wise, we need to embrace that in order to deal with it. Otherwise, right now, scale-wise, we are not there yet. 50,000 containers, I'll be surprised if someone is running more than that at all. Not including Google and these guys, of course, right? I'm talking classic enterprise customers. So with that, collecting data from that, you can even put some centralized stuff to get there, but trying to go beyond that, you start to see the architecture fall apart a little, and you will have to go back and reinvent things.
Yeah, great. Shannon, last word before we wrap up.
Yeah, I couldn't agree more. I would tell you, we just going through our beta to GA testing. One of the big things we really started getting into was some hyperscale testing with a few big users, and there's all sorts of limitations. I can just tell you that. Like, we're running into issues with cAdvisor, all sorts of different things that are, you have to tune the heck out of it to get to tens of thousands of containers running, where you get into 20, 10, 20, 30, 40. You can do it on a cluster, but as soon as your cluster gets into, hundreds of nodes and you're talking about tens of thousands of things, you're pushing envelopes, you're finding that you're breaking things. The most happy users I find are the people that are running more traditional, normal-ish scale applications. It all works great, it's well tested, it's quite resilient, quite reliable. If you're talking about running like massive, web scale applications, you better be ready to, again, if you're running 10,000 of anything, you're probably dealing with your own set of requirements and dealing. So like, good use case that we're working with a bunch of telcos on, some thoughts and work they're doing around NFV and sort of looking at containers in that case. All sorts of issues, all sorts of challenges, and just a lot of stuff to solve. It's all solvable problems. It's just, it hasn't been solved. There's a lot of work there.
Well, great advice. You guys know who to call if you need any help right here. Let's give a round of applause for our panel.
Yeah, thank you.
Lipin, PJ, and Shannon.
Great job, Samir.
And please, a round of applause for DJ, who organizes all this. Thank you, DJ. Over to you.
All right, thank you so much. And I'd like to thank the moderator, Samir. Thank you so much for moderating the entire panel. That was a lot of fun. And to all of the speakers, that was really entertaining. Honestly, that was amazing just listening to you guys talk about all of these things going back and forth. Thank you so much for making the time to come talk to us. And please stick around for any kind of questions that you have. Otherwise, folks, I will go ahead and get these slides from the speakers and post it. And the video links will also be up online on the meetup.com website. Again, thank you so much for coming.
All right.